Upon arrival at an emergency room, patients are categorized according to their condition as critical, serious, or stable. In the past year, 10% were critical, 30% serious, rest stable. 40% of critical patients died, 10% of serious patients died, and 1% of stable patients died. Given that a patient survived, calculate the probability that the patient was categorized as serious upon arrival. So the difference between this problem and the two before it is that the given thing in this case is the survival, whereas earlier the given was the death. Death probabilities were given, and also the given condition was that the patient died. Here we will still make a table as before, but we'll make an extra column. Usually we just have the death probabilities, but since in this case we have to deal with the situation that the given condition is survival, so we also need to calculate the survival probabilities. So make the table a proportion for 10%, 30%, and the rest. So 10% for critical, 30% serious, and the rest would be 1 minus the two other. So we get 0.6, and then the death probabilities of the three types were based on the percentages given were 40%, 10%, and 1%, so it'd be 0.4, 0.1, 0.01. But as we talked before, in this case, we also need the survival probability because that's what the question is asked. So survival would be 1 minus death. So if the death is 0.4, it'd be 1 minus 0.4, 0.6. So 1 minus 0.1 is 0.9, 1 minus 0.01 is 0.99. So we are asked probability of serious given survived. See, given that a patient survived, calculate the probability that the patient was serious. So probability serious given survived would be probability serious and survived divided by probability survived. So serious and survived will be 0.3 were serious, and survive was among them was 0.9, so 0.3 times 0.9. And then in the denominator, we have probability of all survived. So the three types survived, the critical and survived will be 0.1 times 0.6, or which means addition, serious and survived will be 0.3 times 0.9, or addition, stable and survived, so 0.6 times 0.99, and that gives 0.29, which is choice B.